I'm Edward Williams, the old and gray. I've been doing simulation work, as you see here, this brief introduction, and teaching it since the late 1970s. So I've been at it more than 40 years now, more than half my lifetime so far. And now we'll approach the question, which simulation software tool should we buy and use? At PMC, we support many, so we're not indebted to any one. We have a big stable. And our answer to that question starts a nice, long, leisurely shop talk, where we ask many questions relative to the prospective client's context, what they need, and what their capabilities are. Now, to break that down a bit further, our objective is the simulation software is going to be a steady contributor to your bottom line success over a period of years, not just one project, not just weeks or months, years. It's not going to collect dust or serve as a bookend or a doorstop. It's going to be ongoing, steadily used as a contributor to your bottom line. And indeed, at best, any one simulation model is a living document. My own record is 11 years when I was at Ford. And some of the projects done here at PMC that I've helped with or observed, more than that. They've got the 11 years beaten. And to become a living document like that, a model has to be extremely well documented, both internally, comments within the model, and externally. And the new employees I mentor here at PMC would likely tell you I'm an absolute nut up on a soapbox about the importance of documentation. I tell them a proverb, I think it was historically Chinese. The palest ink is more powerful than the most retentive memory. The better a simulation model within a simulation project is documented, the longer and more effectively it can add money to your bottom line as a client and simulation user. So next, perhaps the most basic or obvious question, what will you be simulating? Historically, it was manufacturing processes. That was the first major use of simulation when it came out of the ivory tower into general use. And indeed, that's most of the use I made of it at Ford, but also for distribution and warehousing systems. Will you be needing to simulate the movement of pedestrians or vehicles? Those vehicles might be delivery trucks, they might be forklifts, they might be tugger trains, or automatic guided vehicles. Will you be simulating the movement of pedestrians, such as within a shopping mall? The tornado siren went off. Under the proposed design, how quickly can everyone get into the storm cellar? Will you be simulating retail operations, either a small store or a large one? Simulation can be of great value if it models one operation in a franchise, and then its benefits can be extended all across the franchise. Healthcare services. That's a major one. Even before COVID, that was a major one. It's really booming now. Hospitals, clinics, COVID-19 vaccine and test centers, emergency rooms, doctor's offices, dentist's offices. We've worked on all of those. Transportation networks, such as airports, luggage handling at airports, city bus networks, train networks, and so forth, and etc. Simulation usage is steadily expanding. And when we get this most basic question answered, we typically ask, is your process push? The work moves on as far as it can as soon as it's done. Or is the process pull? The work, well, the work might be a refrigerator you're manufacturing, or a patient you're treating, or a suitcase you're loading onto an airplane, or a meal you're bringing to the restaurant table. That sheer variety draws attention to the versatility of simulation. Is the process push, that's traditional manufacturing, or pull, such as a restaurant cooks a dish only when a customer has ordered it? That can affect the choice of simulation software, because some software is better at one, some software is better at the other. And more specifically, and these questions pertain usually to manufacturing, warehousing, and distribution. Are you going to be modeling and analyzing material handling extensively, to the extent of detail that you need to take into account acceleration, deceleration, different speeds, loaded or unloaded, that type of detail? And the same if conveyors are to be modeled. Now, do workers have multiple tasks? Is a particular worker or type of worker, such as an electrician who's a member of a crew of electricians, is that worker needed to do multiple tasks in different places with different priorities and travel times between the tasks? And simulation software makes it routine to analyze situations where tasks have priority over other tasks, such as the business class passengers board the airplane ahead of the economy class passengers. That is priority, particularly in healthcare. And that, as I mentioned, is getting to be a major use of simulation. You have preemption. The doctor interrupts treatment of a moderately ill patient, such as setting the broken bone, in order to save the life of the person having a heart attack or a stroke. So preemption is the idea of priority on steroids. It's a little more detailed and challenging to model, and some softwares make it easier than others. And what about the modeler? Some of our clients leave it to us over a period of years to build all the models and provide them the results and the interpretation and recommendations. Other clients want to have us make them gradually self-sufficient or nearly so in simulation. We have some clients who have become largely self-sufficient and return to us occasionally for questions of particular complexity. Now, if a client is going to take that route, are the people who are going to learn simulation, what do they prefer to use in terms of programming language approach? And that can depend on their previous industrial experience and the particular training they may have received at university. And with respect to the model, is it going to need to represent using up and replenishing raw materials? An example question that simulation is particularly good at answering is, what should the reorder point be? If you reorder too often and in too great a quantity, you have administrative and inventory carrying costs. If you reorder too rarely or at too low a reorder point, you have risk of stockout. Simulation can find the sweet spot. And in more complex cases like that, a bill of material needs to be represented in the simulation model. Some software makes that easier than other software makes it. And how about pedestrians? For many years, that attracted little attention. Now it's attracting more attention. Nursing homes. The aide might walk fast to a next assignment, but walk very slowly when guiding a person with a cane to a clinic for checkup. Similar things apply on cruise ships. And I put them in twice. They can appear in different ways. The boarding and disembarkation from a cruise ship, how many elevators are needed. Anyone who's taken a cruise knows to wait for the elevator when you first board the cruise ship. Shopping malls, I already referred to that briefly. How quickly can you get everyone into the storm center if a tornado is approaching? Or, very unfortunately, and it's just been in the news, how quickly can you get everyone out if a shooter comes in? And the usage. I've already alluded to the first bullet point. Are you going to outsource the work to us indefinitely? Are you going to have us teach you the software so you can use it directly? Will it be a migration? Some clients, well, we'll build the first model for you. Show us what you're doing. We want to build the second model ourselves, but watch over our shoulder. Then we'll build the third and fourth and fifth models, and we'll keep your phone number handy for tricky questions. And are you going to have enough simulation work to do that you plan at least one person becoming a power user of simulation? And whether that potential power user of your own is more comfortable with object-oriented programming or procedural programming, these questions become important. There is a usual trade-off between analytical power and ease of learning the software. The more analytical power, the more complex the software is going to be. Yet many of these packages have the happy property that maybe 80 or 90% of the package power can be exploited by learning about half of what's in the software. And then if a project becomes more complex, you can gradually have us help you learn the other half. Now, animation questions. Nowadays, simulation software isn't even competitive if it doesn't do good animation. But how much effort is it to get that animation? Do you really care about having three-dimensional animation? You can get very good analytical results without it. Are you going to want to import a file as a backdrop to your animation? If the answer is yes, it's usually an AutoCAD file, and some software does better with that than others. Are you going to want to use your own icon library? Usually the answer to that nowadays is no, because the software has bigger icon libraries in it. And are you going to capture an animation movie and play it back to show management or colleagues? And statistical. Would you like a distribution fitter bundled with the software? Well, first you might want to know what a distribution fitter is. That's actually a technical point. As an example, suppose I've gathered 30 or 40 numbers that represent actual data. When this machine broke down, how long did it take to repair it and get it running again? How do we model the downtime duration of that machine? A distribution fitter will read in those 30 or 40 data points and tell you that an Erlang or a Weibull or a Gamma or a log normal, to throw out a few names, is a very good fit for that data. Or it may tell you that no mathematical distribution is a good fit. And getting the answer to that question is a big help to the modeler wanting to produce more accurate statistical results that reflect the reality of your system. And if you're going to be comparing a lot of alternatives against one another, do you have, or will you want us to use ours, package like one of the two statistical packages listed there, Minitab, Jump, there's many others, to look at the results in order to choose the best alternative for your enterprise? Now, what simulation is particularly good at, you may have a system you model or have us model. It needs improvement. You have several alternatives under consideration for improving its productivity. You may not know it yet. This is why you're simulating. Alternative A may do very little good. Alternative B may do very little good. If you implement both A and B, example, we buy one faster machine and we hire one extra worker, the improvement may be wonderfully large. That's an interaction. Simulation and design of experiments is very good at finding those hidden interactions. It would be a shame to overlook them. And interface. Almost all our clients say yes to the first question. A minority of them say yes to the second question. And a few clients say yes to the third question. They're working with SAP or statistical quality control, enterprise resource planning software. And will the boss open the purse? Now, in my 40 plus years of experience, a 10-to-1 return on investment in the simulation project, and by investment in the simulation project, I mean the software cost if you buy the software package, and the cost of time to build the model. And there's a third cost that always has to be included, the cost of people's time while the modeler is gathering data to put in the model. It would be no fair to overlook that one. And considering all those as project costs, your first project is likely to have a 10-to-1 return. Occasionally, I've seen 100-to-1, but 10-to-1 and up is routine. And when you're trying to get the boss to say yes, that's a valid and important point to make.